Okay, Assalamualaikum guys. So today's we continue our lesson for the lean manufacturing. Yeah. So in this topic we already learned. So I hope you get, understand, and apply the concept of lean manufacturing and JIT as a manufacturing strategist. Understand the importance, the lean, understand the importance of the lean manufacturing and JIT as manufacturing strategies. And also understand the philosophy of lean manufacturing as a manufacturing strategy to minimize waste in the production environment. So lean manufacturing and just-in-time system very related to the waste. Very related to the waste. So as lean manufacturing is one tool to eliminate the waste from the Shigo Singo. They said that the most dangerous kind of waste is the waste we do not recognize. So that is very dangerous part. So when we not recognize the waste, we cannot do a elimination. So that's why in Japanese company they do the JIT lean manufacturing too. This system is very famous, in the Toyota. They call it a Toyota production system. So we will explain later in the previous slide. So in this part, we will need to recognize the waste, and then from there we can eliminate the waste. So the most dangerous kind of waste is when we do not recognize the waste. So that's why we need to find out, to using the tool available to find out the waste. So reduction the waste, we have learned this push system and pull system for the assembly line. So what is the push system? So I will go back to that figure later. So every workers maximize own output, making as many product as possible. So that is a push system. So push system normally in the cell, in the job shop, they use this push system because they depend to every workers, every single workers, every machine that can be produced, they maximize the production. Normally they build the production in the cell in the previous slide for the range production in the range from the middle small to the high volume production. They depend to the maximize the own output at the station. So when they make the output, they increase their production, they have a buffer in the stock. They produce a lot of production, and then they will keep, and of course we need some space to keep that production. For sure in the production line we have individual station, individual cell. So when this cell produce more production for their output, they will have a buffer stock to the next level production. So this item will need some space to keep, either in the production line or in the warehouse. We need to keep, and then the space become some waste. Of course, when we do a lot of buffer production, they have some pros and cons. So the pros and cons is focus on keeping individual operator and workstation busy rather than efficient use of material. So the operators normally in some company, they keep the operators their manpower busy, the machine busy to operate rather than to see the efficiency of using material. So the volume of defective work may be produced. When we did a buffer production, they do it a lot of production in the one time, so they cannot trace that maybe inside that buffer stock they have some defect product. So Normally in the cell, in the job shop, we need to do a final inspection at the end. You can see in the continuous production, we have every station, assembly station in the from one station to another station, and at the end they have a inspection for quality check. So that one is very good because they can see each product each time. But for the buffer, for the this push system, they just produce whatever product, and then maybe at the end they see the defect product. So what happened? So the time to eliminate the waste, to find out the waste, to eliminate the quality defect product is very difficult. So this is become bad to the production. We cannot do a high quality. Throughput time will increase as a work in process increase. So work in process increase. So as a buffer, they have one stop there. So even though they need to do a progress in the next level, but the throughput time will increase according immediately when we do a buffer stop. Line bottleneck and inventory of unfinished product will occur. So line bottleneck, so of course when we have one station doing a lot of production, so when the next process have a slow production, they will have buffer in the middle of the line. So that buffer will be a line bottleneck. So we will have increased the inventory, unfinished product, and then hard to respond to special order or order change due to the long throughput time. So we cannot do a improvement in the line, for example. Very hard to trace, very hard to change the layout, everything, because they have doing at their own station for their own focus. So every workstation maximize our own product, and then making as many product as they can. So they will keep the operator or workstation busy. So there is a pro and con for the pull system. And then we also have a pull system. So what is the pull system? A pull system is a production line is controlled by the last operation. We have a line just now. We have one station, two station, three station, and then last station for inspection. This is a final finished product. So it's the last station in the line. They control overall the line process using what? Using Kanban card to control the operation. So what is the Kanban? Kanban, I think, I will explain later. We have slide on that. So before that, we go for pros and cons for the full system. So pros and cons is control maximum work in process and eliminate work in process accumulating at bottleneck. So because they use the system, pull system, they get the orders or requirement from the customer. For example, the customer required 100 pieces, 100 unit product for that time. They order 100 unit. So the order coming from the warehouse or from the sales to the production control, and then they pass to the representative line to produce that product. So from the finished section, they will they will require the material. So they will produce the part based on orders coming from the customer. For example, the request is 100 unit, 100 pieces. So the quantity of the material will come at the first process is 100 unit pieces material. So they will produce all that only quantity for that one. So they will eliminate the waste, and although even though the bottleneck also they can control, because the process just in time, just in time, and then keep material busy rather than operator. So they just supply the material for 100 pieces to the line, and then that material only will move to the line, and then operator work on that. So if a problem arises, there is no slack in the system, so they can easily trace the operator in the line, problem when erased in the line. Throughput time and work in process are decreased, so they will decrease the throughput line because the product will supply at the station for each order required or given by the last operation. So from this chart you can see we have a Kanban system. For office also they have so many things to do. For example, they make a to-do list using a Kanban, using the card. Kanban is the card that have a barcode and the instruction there. So for example, they have one Kanban, they have a part number and then barcode, and then the 1, 2, 3, the material used for that particular part to assemble. They put in the one piece of paper, and then if this paper represent for 10 unit, so the Kanban for 100 they need or 100 Kanban to produce to that line. Similar to this thing, to the office work, they have listing in the play card, paper card inside to do. So when they want to do this job, they will take this one and then they will put inside this one for that particular day. For example, from this list they are doing for this one. For example, they have one, and then after finish they will pass to the done, and then another Kanban will come out. So the process will more systematic. Similar to the production line, they come from the finished part, they have Kanban here, they will take and then they will bring to the warehouse, and then warehouse will bring the part, and then they will put the material based on orders. So the Toyota production system, TPS, the system, a system that continually search for the waste throughout the value chain. So Toyota production system is a good system. They as a tool also using the just-in-time system to find and search the waste and eliminate the waste throughout the value chain. Value chain, they have suppliers. For Toyota, they have a subcontractor. So the values, the change to produce that product from the customers, from the sub material, from the vendor, subcontractor. They make this system, use this system to find out the waste and eliminate all those waste. And then view every enterprise activity. TPS is Toyota production system. View every enterprise. Every enterprise, their subsidiaries to find out to view the activity and then find out the waste and then reduce the waste. That is the activity. And then from customers to the board directors to support staff, all staff involved, from customer, BOD, supporting staff, operator, engineer, involved inside the production plan to do this task. So for Toyota production system, they always customer focus. They refer lead time, cost and quality to produce a high-speed product, to produce just-in-time system to customer with low cost with higher quality. So that is the focus of Toyota production system. From this focus, they using the just-in-time tool to see the waste and then to eliminate the waste. To see the and then the to use the involvement for all staff using this keyword and then to do a automation. From there also they do a standardization of work. They standardize everything and they standardize the procedure, the manual, so the work become more smooth. So eliminate waste in Japanese called muda. Muda is waste. Muda is waste. We have an acronym close mean. Close mean acronym is refer to the C for complexity, L labor, O overproduction, S space, E energy, D defects, M material, I inventory, T time, and T transportation. Close mean for elimination of waste. So complexity is to make process more simple. So when we make simple, we can reduce the waste. Levels don't waste people time. So when we plan well, we use the correct level inside the line, and then we can reduce the waste in terms of energy, salaries, and waiting time, and then overproduction. So don't make more than customer needs. So normally in this system, they just based on pull system, Kanban system, they just make a production based on customer requirement. And space cost of money. When we do only the right quantity of production, they will reduce the space for the produced lot of buffer stock. So for sure we need the efficiency for the delivery to the customer, because the lead time also become priority. So we need the change, the supply chain is ready. So whatever material needed to produce the quantity given by the production line can be produced immediately after they get the order. Even though if we consider to make a buffer to cover when the order increase, it's not allowed in this system. We just produce whatever ordered by customer, and then we can reduce the space for the storage, store the stock inside the warehouse operation line. And then energy also we can reduce, because the running machine, heating facilities, and keeping the light is costly. When we do a lot of production, of course we use a lot of utilities, we use a lot of manpower levels, and then they do extra overtime, so we waste on salary also. So the energy waste is related to all others also. And then defect products. When we doing the buffer stock production, doing things twice costs twice as much as or more than doing the right thing at the first. Because when we doing the right thing at the first, we just doing the one by one in the right time to do an inspection, rather than we do a lot of production in the one time in the buffer, and then we leave it to another process to check it, and then when the process is skipped, we have a quality issue on that, we have defect on that. When we want to trace it, we need to do for the lot, for example, we have a 100 unit production for that lot. We need to trace one by one to find out where the defect product is. So we waste our time. So we waste also to find out the defect, and then we waste also to do the rework process to repair that part. So if we do the right thing in the first time, so of course we have save on the time, save on the to find out, to do rewards, everything. So we save a lot of money on that, on this part. And materials, look in your dumpsters for scrap. Make sure you are using material efficiency. So material, the right quantity for the right material, quantity for the right quantity orders is good. So we can eliminate the waste. Idle inventory or idle materials. Idle material is another name of inventory. Whether it's raw material, component or finished good, a great deal of money is tied up in purchasing and managing inventory. So inventory, we need to store it, we call dead money, because we cannot convert that one to the money until we deliver to customer or make use that product. So there will some waste there. Times is non-renewable resources. Renewable resources, don't waste it. Time can be in the form of waiting for the process to finish, shutting down key process for break or lunch, waiting for communication. The time is very important. And then transportation, move staff, people, material, the extra. So they need time and space. Take time and space. Anytime someone is working somewhere or for at least moving, so you waste time for the transportation thing. So that one also need to eliminate by rearrange the method of productions to eliminate the working or transfer time. And so we will do a lot to increasing our productivity using this acronym, close mean. So the other tools to eliminate waste is 5S, group technology, quality of soft, JIT production, Kanban production system, minimize setup time, uniform plate loading, focus factory network. There is a tool for elimination waste. So for example, we give explanation more for the 5S, because 5S very famous system in the companies, not only in Japan. So in Europe, in Asia, they use this system in their manufacturing. They adopt this culture to eliminate the waste. From Japanese, they have a series, Seton, Seiso, Seketsu, and Sike. There is all wording for the 5S. They come from the S in front of this Japanese word. So good factory develop beginning with the 5S, bad factory fall apart beginning with the 5S. So we need to sort, series, simplify, swap, standardize, sustain. So there is 5S. So a place for everything and everything in place. We need to put a place in right place and put back, use, and then keep the housekeeping. And then critical foundation for setup. Critical foundation for setup 5S is for setup reduction, full system maintenance, inventory management. And this is an example for 5S. In the beginning, we need to do a sorting. After we sort everything, we put in order. And then we clean up everything. So we do a manual standardization to follow up. So when things in order, sort, signing, so we make a standard. And then we follow, we sustain that one. So we follow everything, this one, every day. We follow the standard what we did. So there is 5S. This example for 5S in the factory, they keep improper, they have a tagging everything. So they look very proper. So minimize waste. Another tool is using group technology. So you can see here we have process here using saw, and then after saw they go to pass the workpiece to the lathe. After finish lathe, they pass to grinder section, do the grinding, and then pass to heat treatment, and then heat treatment they goes to lathe again, and then after lathe process they go pass to the press section and then finish. That is the flow for the existing process. They have a group, saw machine, lathe machine, grinder, press. They group this kind of layout. So this one can eliminate the waste through rearrange back the process. For example, they rearrange from the group to more related to the process. So from the saw, they have 1 and 2 A and B line. So normally this you can see here, when after finish saw, they pass to the grinder, to the lathe, and then the lathe is they have grinder beside the lathe, so they reduce the transportation distance there, time also reduce, and then after finish dispose, and then they pass to the heat treatment, and then at heat treatment they have to transfer to lathe and then press and finish. They have 2 line here, so if this production congested here, they will pass to here, so they will reduce the time of waiting there, and then they have good capacities for the machine to build up the orders. When they have a double order, they can use both to do operation. If not, they just use this one. And then similar to this one, they have similar setup to this one to double up the production, rather than this put in the group machine. They each section they finish, they go to this section, they go to lathe section, they go to press section. They become waste on the rearrange the machine, and then using a lot of time in the transfer the workpiece. And then we also have JIT. JIT is a just-in-time system, so only produce what needs. The opposite of just-in-time system is just-in-case. Just-in-case philosophy. We use this one. So when we get that one, we produce. So either lot size is 1. So we just have either in one lot size only, rather than we put focus on the machine to produce a lot of buffer stock. They have either in the lot size so many lot there, but for this one they just produce and then put in the one lot, and then after finish one lot they deliver. After finish one lot they deliver. So either lot size is only 1, and then minimize transit time, and then frequent small delivery. They have a frequent delivery but in small quantity, but very efficient, very reduced cost in terms of using the small lorries to deliver the part to the customers. So pros is minimal inventory, less space, more visual, easy to find out when we want to find the defect. Easy to monitor the workpiece what we produce, so more visual. Easier to spot quality issues also when we will find the defect product. We have a one lot size only with the small quantity, so we can easily to spot when the quality issue arise. And then cons is a required discipline. Of course we need to have discipline, because when order coming we need to produce and deliver. Order coming we produce and deliver, so we need a discipline in terms of material, in terms of production, in terms of transportation to deliver the orders. There is need to have a discipline, require a good problem solving to find out the issues when to find out the quality issue. For example, we have require a good problem solving when we have a line, a production line, we have a station, conveyor, and then if this one break down, we need to react fast to find out this problem, and then If not, all production will stop and then we cannot deliver, because we just have either in the one lot size, so we need to recover fast, and then require high efficiency and qualities. So inventory high problem, of course, when we make a lot of production and then put in the inventory, we hide a lot of problem. For example, machine downtime, scrap, work in progress, paperwork, backlog, engineering, design redundancy. We cannot trace that one, and inspection. So we hide everything. Of course, we need to see this one, eliminate the waste, and then we can serve a better quality product to the customers. And then using the quality at the source, like unknown system. Unknown system is the alarm inside the production line. They have a flow process here, product flows in the line, and then this operator have facing some problem. They pull this or switch on the system, trigger the switch, the unknown way blinking here. So the engineer already know the number 8 is having some problem. They go and then do a fast counter measure to do a fixing to that line. So there is a unknown system, fast reaction. And then using Kanban, this one I already explained to you. We have a card system, empty container, light or color golf ball to show, to give the signal, the device that control the material flows. So from the order for customer, we will translate to the part will produce, and then the material that required to produce that part, and then the material we bring out from the warehouse and then pass to the production line based on the Kanban that give instruction to do to pull the production. And then setup time also can minimize the waste. Long setup time derive long production run, large lot, long lead time. So just in time system require small lot size and minimum Kanban, and then setup reduction. They focus on effort, problem solving, and flexible equipment. We also learn about Hejungka, that is a plant loading. So in Hejungka, they suppose we operate a production plant that produce a single product. The schedule of the production of this product could be accomplished using either or two plant loading schedule below. They have a number. For example, the table schedule, they have January, February, March, the quantity of orders, the total is this one. So they do this one like this example. From the order, the quantity order, they will split by the Hejungka box. They have a Kanban also. The Kanban we instruct for the from the order, for example 3,000 just now, they divide to the type of order by card. So card number A will type A, we will pull this card to produce. The operator will take this one. This card is represent the orders, the Kanban. And then minimizing waste, focus the factory network. So this one refer to the coordination system integration. So when this factory, for example, produce for casting product for the bar steel, for example, or casting product or bar steel product. So they just produce this one, and then the company they have integration coordination system. So they will take from this company. So they will have a ordering system. They have a connection, and then they will also have another company to do a small part, for example. So they focus, and then they have network for different company, and then the system coordination integrate each all company together, and then this will minimize the waste. For example, minimize the waste to produce the part that not become core for that company. So for example, this company focus on casting, the others company will focus on the machining, for example. So they part the casting product and then just do the machining there, and then pass to this company for assembly line. So this one only focus for assemble. So the network coordination system is very good to eliminate waste, and then to make more profit, and then more efficiency, and focus into the quality also. And then K-Racer is respect for people. In the Toyota production system, they have K-Racer. They see the level payroll, cooperative employee union, subcontractor network, bottom up management. So bottom up management style, quality circle, small group problem solving. So in the K-Racer, they involve all parties. So in company, normally top down, for example. So now they use the bottom up management. So from the bottom, they bring up the issues, and then they see the find out how the solution are, and then they don't have level for the management for according to salary, according to their so their level also same, not according only salary, and their levels, their department. So they can focus on respecting on the people, and then they focus on the work together to find out, to do a problem solving, to settle the quality issues, make a quality circle that involve everyone inside the circle. So when they top management see the presentation from each group, for example, we have a small group activity, small group Kaizen activity. In Kaizen is a small improvement in Japanese. So when we have a small group activities to find out the quality issues, they involve all department, all levels, payrolls or union inside. Even subcontractor also will be involved inside the quality issue to find out the problem, and then solve the problem immediately. So this is a K-Racer, respect for people and doing together. And then Toyota production system, they have 4 rules. All work shall be highly specified as a content, sequence, timing, and outcome. Every customer supplier connection must be direct, and there must be unambiguous yes or no way to send request or receive response. The pathway for every product and service must be simple and direct. Any improvement must made in accordance with the scientific method. Scientific method under the guidance of teachers. For example, I explained before, we have a small group improvement. So in the small group improvement, normally we have some engineer to guide for that process or project. So we find out the problem, and then we will do a recommendation of solving problem, and then this involve guidance from the teacher. So rule is highly specific, content, sequence, and customer connection must be direct, and then pathway simple and direct, and scientific method. There is 1, 2, 3, 4 rules for TPS. Lean manufacturing implementation. So empower workforce problem solving, performance measurement. That is core for the lean manufacturing implementation. From there, we have quality management, flow process, stable schedule, Kanban pool, involve supplier, continual inventory reduction, product design to do a problem solving, to eliminate waste, to do a performance measurement. So lean tool, this is a tool for the lean. We already cover 5S, Handout, standardization, TPM. Pokayo is a foolproof production. Kaizen is small production, automation, 7 ways, just in time, Kanban, Jidoka, automation. There is a lean tool to find the ways, to eliminate the waste, to simplify the production, to create flow more easy, simple. There is continuous improvement, focus to customer, to give a product activity and quality increase. There is a lean production, and then this is a lean tool. Summary and conclusion. A lean production is the set of activity. Lean production is set activity that achieve quality production at minimum cost and minimum inventory, because we eliminate waste, we do it in time, we minimum the cost, and then we maximum the quality of the product. And then the flow of material pull system. So we based on the customer or downstream operation, order from the customer. So from the order from the customer, we take the control the line to move based on that decision, that orders. And then the material supply also based on the orders from the customer. And then the lean originated with the TPS. So we already touched about TPS tool. Is similar to the lean, because lean originated with the TPS system, and its two philosophy: elimination, waste, and respect people. So we have two philosophy: eliminate the waste, respect people, work together. There is lean production or lean manufacturing with the Toyota production system inside there. You have this one. Close mean is the tool for eliminate waste. So close mean is a form of waste. I think that's all. Thank you. Assalamualaikum.